Okay, here we have a circuits question. We've got identical resistors R1, R2 and R3. We know their resistance, and we're being asked to calculate the power dissipated by R1 when we close the switch. As ever, please have a go at the question and then watch on to see my explanation. Okay, so let's go for it. So let's start off by remembering our equations here. We've got a voltage divider essentially here, and we're going to start off by using the equation P equal V squared over RY. Well, we know the power and we know the voltage, so it kind of makes sense here. All right. Now, originally, we can apply this equation to any of these resistors, depending on how we're looking at them, and so it's a really useful one to use here. Now, initially, we know that the power is 18. We also know R, and so therefore we can use that to calculate V squared, okay, which is going to be 36 V squared, right? Now, why are we doing that? Sometimes you don't know exactly why you're doing these things. Okay, it'll become clear. We know that V squared is equal to 36 V squared, okay? In other words, the voltage across R1 is equal to 6 volts. Yeah, we have 6 volts across there. Why is that helpful? Well, we've got 6 volts here, and we've also got 6 volts here, all right, which means our EMF of our supply is equal to 12 volts. Okay, now notice here, this is really all in the setup of the question. We're using this to make sure we know what's going in, because when we close that switch, these voltages are going to change depending on the value of R. Okay, when we close the switch, our voltage here is going to change from 6 to 4. Now, why is that? It's because we've got 2 resistors connected in parallel. Okay, when you connect 2 resistors in parallel, the resistance halves, and that means we're going to get 8 volts here and we're going to get 4 volts here. Yeah. Now, we're going to get 8 volts there, as we can see here. Why is that important? Well, actually, we now calculate our new power across R1. We know that we've got a new voltage of 4, okay, which is going to get squared to make 16 divided by 2. It's going to be 8 watts, which gives us a power of 8.